honor students. Today we're actually going to be doing some flipping the classroom. You are going to actually be learning the lesson at home, and then when you come to class we're going to do an activity or two to support it, but not actually take the notes in class. So you should have your notes in front of you, and you should pause or stop this video anytime that I'm ahead of where you are in taking your notes. We're actually looking at chapter 2.2, the distributive property, and I love teaching the distributive property because you use it so much in algebra, and I know you probably did a little bit of this last year, but we need to start at the beginning to make sure that you understand it and you've got a good solid handle on it. If we think about the word distribute, now I think I'm better now. If we think about the word distribute in English, we think about it meaning handing out, pass out, give one to everybody. If I distribute something, generally we think about distributing it evenly, and it means pass out or hand out. Well, in math, the word distribute really sort of means the same thing. It means that we are going to distribute a factor. So we've got a multiplication problem going on because we've got the term factor. We're going to distribute a number or a variable evenly across everything that's located within a set of parentheses. A bunch of addition or subtraction, whatever's within the parentheses, it doesn't really matter. The distributive property uses parentheses or some other kind of grouping symbol to tell you that they want you to distribute from the outside to the inside. So we're going to look at some examples. These first four examples are actually just illustrating the distributive property. It is a formal property in math, and it's written with variables. So what it's saying is that if you have three different variables, A, B, and C, and you distribute what's on the outside of the parentheses, multiplying A times B, you get AB. If you distribute or multiply A times positive C, this sign is important, you end up with a positive AC, and your parentheses are gone. That's the important thing. The parentheses are gone. Our property, our commutative property of multiplication, said it really doesn't matter whether this A is in the front or the back of your parentheses. You distribute it the same way. We multiply A times the first term, which is a positive B, we get positive AB, and we can write it BA. And we do the same with the second term, and we multiply or distribute A times positive C, and we get positive CA or AC. I've written it both ways, so it will remind you that the commutative property says we can do either way with this. Let's look at if we have a negative term on the inside of our parentheses. These signs are very important. A is positive, so when I distribute him to a positive B, his sign's not showing up, but we know he's positive, he becomes positive AB because a positive times a positive is a positive. However, C is a negative dude. That sign says that C is negative. So when you distribute a positive A, or multiply a positive A times a negative C, you get a negative AC. And this sign right here is what's easily missed by most students. And then you can just see the reverse of where I put A on the back end instead of the front end, illustrating the commutative property again. So let's work with some expressions. Let's work with some examples so you'll get more comfortable with what we're talking about here. I see parentheses and a number out in front that tells me distribute. There's the instructions. Use the distributive property to write an equivalent expression. That's important. It says that the expression that we're going to end up with has the same value as the one we started with, just a different way to write it. So 9 times A is 9A. Positive 9 times positive 6 is positive 54. And you're done. It's that simple. You've distributed, you have no more parentheses, and you've done what they've asked us to do. Let's look at number 2. Distribute 4 times 2x. Well, you can multiply the 4 times 2 and get 8x, and it's positive. And you multiply a positive 4 times a positive 7. That's a positive 28. And again, you're finished. Pretty easy, right? Okay, let's keep going. Page 2 for me. Okay, we've got a bunch of examples. I'm going to kind of fly through a couple here, and if you need to pause the video, please do. Make sure that you understand what I'm saying and that you are with me on your signs being correct. 3 times y, they're both positive, so we have a positive product. Positive 3 times negative 12 is negative 36. Moving on to number 4, negative 32x. And here we have a negative 8 times a negative 6. We get a positive 48. So the sign on the outside guided distribute is important, and the sign on the inside of the parentheses is equally as important. I've got these all numbered kind of weird. Look, I've got 3, 4, 6, 5, 5, 7. That doesn't look too good. I hope your notes are yeah, I think your notes are exactly like mine. I'm looking at a copy, so my numbering is off. That's all right. We'll keep going. 6x times 1 is a positive 6x. 6x times a negative x is a negative 6x to the second power. X times x is x squared, and 6 times the number that's here, there's really a number there. You don't see him, do you? I call him the ghostly 1. This is really 1x, and he's negative. So when I multiply the numbers together, 6 times negative 1, I get negative 6. And when I multiply the variables together, x times x, I get x squared. Let's go up to the first number, 5. Negative 6 times positive 6, negative 36. Negative 6 times negative 2x, and I get a positive 12x. The second number 5 is an interesting one because there's no variables here. So we've got one of two choices. We can distribute like we've been talking about, so let's do that. Let's multiply this negative 3 times all 3 pieces that are on the inside, and we get 21, positive 21, minus 15, plus 6. And now, because it's all numbers, we're not finished simplifying. You don't walk around saying you're 10 plus 2 years old. You go ahead and add them together and get 12. Well, we've got to do the same thing with this. So 21 minus 15, we do this guy first, is 6. 6 plus 6 is 12. And that's our final answer. There's another way to say how old you are. If you're 12, you could say, I am 21 minus 15 plus 6. Cool, huh? People would think you were nuts. But there's another way to even approach this problem to begin with. Because these are all numbers and because the parentheses are a grouping symbol, we can wait and do the distribution after we've added these 3 numbers together. So negative 7 plus 5 is negative 2, and negative 2 minus 2 more is negative 4. And now our distribution becomes negative 3 times negative 4, and our answer is positive 12. So you see, we're going to get the same answer either way we do it, but when it's all numbers, it's our choice. When there's variables in there, you have to do the distribution first. All right, I'm going to let you do number 7 on your own. You can pause the video and do it now, or you can come back and do it when the video's finished. I want to skip to number 8 because here is our friend the ghostly 1 again. There is a 1 in front of this, even though you can't see it. This negative sign by itself really says negative 1. I want you to distribute negative 1. So when we write the 1 in, which I think it might be a good idea if you did that, if you say negative 1 times x, that's negative 1x. Or you might just write it negative x without the 1, and that's fine. And then negative 1 times positive 6 is a negative 6. And you're done. Okay, let's talk about the reverse of the distribution property that we've just done. We're going to go back the other way now. Notice these examples, neither one of them have parentheses in it. So you might say, well, I can't distribute because there's nothing on the outside of parentheses to distribute. But if I ask you to use reverse distribution, I'm asking you, how can you go back the other way and end up with something on the outside of something in parentheses? So you look for what's in common. What might we have that we could divide out of both of these terms and stick on the outside so that when we multiply him back to check our work, we end up with what we started? Well, I see a 2. There's a 2 that I can divide out of this term, and there's a 2 I can divide out of this term. And if I do that, then what do I have left? I have x left, and I have 4 left, and I've taken the 2 out of it. These are easy to check because to check, you just distribute yourself back again and see if you ended up with what you started. 2 times x is 2x, and 2 times positive 4 is positive 8. Now, I made a really big mistake up here because I wrote on the original problem. And if I were giving myself a grade, I would mark myself down because we never write on the original problems. Let's do number 2 together. I'm going to copy the original problem over, so if I do what can I divide by, I can do it without writing on the original problem. What can I divide by? Well, I hope you all see that there's a 3 that I can divide by, and I can take that problem. 3 goes into 6 2 times, and 3 goes into 9 3 times, and I have to take my 3 to the outside. Now I have a distribution problem. I need to figure out if I've done it correctly. Are these 2 guys, this guy and this guy, are they equivalent? Are they equal? Well, let's distribute. 3 times 2x is 6x. 3 times positive 3 is positive 9. And yes, that's what I started with. So are you getting the hang of reverse distribution, I hope? Okay, I think that what we're doing next is on the back of your page. We're going to find the area of a couple figures. And you might guess that we're going to use distribution when we're doing this because that's what we're learning about today. So what I want you to do first, when you get a problem that looks like this, and you have an expression like the height of this triangle is 2y plus 1, you need to put parentheses around him. That's going to tell you that we're probably going to end up having to distribute somewhere. And the same thing on this rectangle. So when we're finding area, we're always going to write the formula. The formula for the area of a triangle is 1/2 base times height. And this is the formula I want you to use. I know sometimes some of you use base times height divided by 2, but I'm going to show you why I think this is a better way to write the formula. Now, plug in what you know. We don't know the area. The 1/2 is part of the problem. Here's my shell. I'm going to write down my base and my height. The base, get the calligraphy pen back up here. The base is 16. The height is 2y plus 1 in parentheses. Now I have 3 terms to multiply together. The associative property of multiplication says it doesn't matter which 2 you pick to start with. So I am going to pick 1/2 and 16. 1/2 of or times 16 is 8. Bring it down. Don't forget the parentheses around the 2y plus 1. Now I'm almost finished, but I need to distribute to get my final answer. So I'm going to distribute the 8 to the 2y and get 16y. I'm going to distribute the 8 to the positive 1 and get positive 1. My area is 16y plus 8 square units, whatever the units are. I want you guys to try the second one on your own, please. Please be